Bapu. Greetings, all of you. Today, I'm gonna teach you about Newton's law of motion. So, our topics are laws of inertia, F is equal to ma. Then, third topic is actions reaction. So, while most people know what is Newton's law, say many people do not know what they mean, or simply do not believe what they mean. Now, Newton's law of motion. So, first law states that an object at rest will stay at rest, an object in motion will stay in motion at constant velocity unless acted upon an unbalanced force. In second law states that force equal mass times acceleration. Now, in third law, for every action there is an equal and opposite reaction. Now, let's just learn this into deeply about first laws of motion. An object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon an unbalanced force. Now, you may see this example. Inertia is a tendency of an object to resist changes in its velocity, whether in motion or motionless. Now, second example, once airborne unless acted on by an unbalanced force, gravity and air fluid friction. It would never stop. Now, third example, unless acted upon by an unbalanced force, this golf ball would sit on the tee forever. Why then do we observe everyday objects in motions slowing down and becoming motionless, seemingly without an outside force? It's a force which sometimes cannot see friction. Objects on Earth, unlike the frictionless space the moon travels through, are under the influence of friction. Now, what is friction? There are four main types of friction: sliding friction, ice skating, rolling friction, balling, fluid friction, air or liquid, air or water resistance, static friction, inertia friction when moving an object. Now, slide the book across a table and watch it slides to a rest position. The book comes to a rest because of the presence of a force. That force being the force of friction which brings the books to rest position. Now, in the absence of force of friction, the book would continue in motion with the same speed and direction forever, or at least to the end of the tabletop. Now, Newton's first law and you. Now, don't let this be you. Wear seat belts. Because of inertia object, including you, resist changes in the motion. When the car going 80 km/h stops by brick wall, your body keeps moving at 80 m/h. Now, second law, F is equal to m into A. Now you may think, what is this? Don't worry, we're going to learn this. Second law, the net force an object is equal to the product of its mass and acceleration, or F is equal to ma. When mass is in kilogram and acceleration is in meter seconds, the units of force is in Newton, which we denote as capital N. 1 Newton is equal to the force required to an acceleration 1 kilogram of mass at 1 meter second. Second law, F is equal to m into A. How much force is needed to accelerate an 14,000 kilometer car to meter per second? Write the formula. F is equal to m into A. Now this law states how to solve the examples. Now this is in reference to all of you about second law. Newton's second law proves that different masses acceleration to Earth at the same rate but with different forces. First, we know that objects with the different masses accelerate to the ground at the same rate. However, because of second laws, we know that they don't hit the ground with the same force, which is F is equal to ma. Now, what is force? Force is a push or pull that cause a change in motion or an object. Now, in first image, you may see the gravity and earth. In third law, for every action, there is an equal and opposite reaction. For example, according to Newton's, whenever object A and B interact with each other, there exist forces upon each other. When you sit in your when you sit in your chair, your body exists a downwards force on the chair and the chair exists an upward force on your body. Now, there are two forces resulting from this interaction, a force of a chair and force of a body. These two forces are called action and reaction forces. Now, Newton's third laws in nature. Consider the proportions of a fish through the water. A fish uses its fins to push water backward and turns the water rig by pushing the fish forwards, propelling the fish through the water. The size of a force on the water equals the size of the force on the fish. The direction of the force on the water backwards is opposite the direction of a force on the fish forwards. Third law, flying gracefully through the air birds depends on Newton's third law of motion. As the birds push down on the air with their wings, the air pushes their wings up and gives them lift. Consider the flying motions of bird. A bird flies by use of its wings. The wings of a bird push air downwards. In turn, the air reacts by pushing the birds upward. The size of the force on the air equals the size of the force on the bird. The direction of the force on air downwards is opposite the direction of the force on the bird, which is upward. Action reactions force pairs makes it possible for birds to fly. Other examples of Newton's third law. The baseball force the bat to lift an action. The bat forces the ball to right the reaction. Third law. Consider the motion of a car on the way to school. A car is equipped with wheels which spins backwards. As the wheel spins backwards, the grips the roads and push the roads backwards. Now, the reaction of a rocket is an applications of the third laws of motion. Various fuels are burned in engine producing hot gases. The hot gases push against the inside tube of the rocket and escape out the bottom of the tube. As the gases move downwards, the rocket moves in the opposite direction. So this is what are Newton's laws of motion.